Hey everyone. In this lesson we're going to continue working on the same things that we were working on both before this whole mess started, and then also in the most recent video from a couple of days ago. So we're going to finish off working with points of intersection examples, and I think this will be the last video that sort of covers the things that I wanted to cover this year with you guys. Obviously we didn't get into our quadratics unit or anything like that, but hopefully that's something we can get into at another time, possibly over the summer or next year or something like that. Yeah, I'm going to make this lesson on points of intersection, and then if I get a chance tomorrow I'll make another one that'll just be on some fun math tricks or some maybe interesting ideas in math that you haven't necessarily noticed before or discussed before. So we'll go through that as just sort of like a fun last day that's not really connected to the things that we've been doing so far. Obviously there's not going to be any sort of test or exam on this now, just because of the way things have gone with the last couple of months of the school year. It would be a bit messy to try and put together something like that now, and wouldn't really be fair to you guys after not doing this kind of thing for a couple of months now. So what we'll do today is we'll just finish off. We'll go through points of intersection, just a couple more examples similar to yesterday's. One that'll be exactly like yesterday's but with different numbers, and then one that's just a slightly more complex version of the problem we did last time. So we'll finish off with those, and then that'll be just about it, I think. So I've worked out two problems. We'll go through them one at a time, of course, and then we will graph them just to check our answers. So we'll go about them the same way as we did yesterday, where we graph at the end instead of at the beginning. So this is even more point of intersection examples. That's supposed to be a happy face. There we go. Alright, so so same deal as yesterday. I'm gonna continue the numbering as though this is the same lesson as the one we were doing before. So this is problem number 2 out of 3, because it's the same style as the last one that we did. So I'm going to give you the two equations, then we'll work through the problem to figure out the point of intersection, and then we'll take our answers and compare them to the graph of the two lines that we get. So the two lines that we have for this problem are, line number 1 is going to be y equals 1 over 4x plus 1, and line number 2, or equation number 2, is going to be y equals 2 over 3x. So when it comes to graphing, we'll revisit the equations themselves and figure out the slope and the intercept and stuff, but basically what we need to remind ourselves of is that what we're dealing with in this type of a problem, the thing you need to remember is what it is you have in front of you and what you're trying to figure out. And sometimes, even if you forget the process, if you understand the idea behind it well enough, sometimes you can figure out how to get from the question to the answer just by using logic. So basically what we have, obviously I'm not going to draw these super accurately, but we've got a line that's got a slope of 1/4 and a y-intercept of 1, so it might look something like this. And then we've got the second line that's got a slope of 2/3 and the y-intercept is 0, so it might look something like that. So basically, I mean, don't sketch that in right now, because we haven't drawn those lines with any sort of precision yet. But basically what we're dealing with here is we have two lines given by these two equations. So we've got line number 1 and line number 2 that are described by these equations over here. And what we're trying to figure out is what are the coordinates, the x-coordinate and y-coordinate, where they cross each other. So that's the point of intersection, is where these two lines will cross each other or intersect with one another. So in order to do that, the way we did this last time is we noticed that at the point of intersection, the y value has to be the same for both points, right? Now also the x value has to be the same for both points, but the first thing we use in getting to our answer is the fact that the y value has to be the same for both points. So that means that 1/4 x plus 1 equals some number y, and this y has to be the same as this y at the point of intersection, right? So this number and this number are going to be the same at the point of intersection, which means that this whole thing and this whole thing are equal at the point of intersection, right? So basically what we have is, if we take this first bit, so we've got 1/4x plus 1, and that's equal to y, right? We know that from equation 1, but this y is the same as this y, and this one is equal to 2/3 x. So I can say equals 2/3 x, like that. I'm going to get rid of that there, and I'll get rid of that as well, we don't need that. So basically what we have is this equation down here, right? This part right here came from equation 1, and this part right here came from equation 2. So at the point of intersection, that y value is going to be the same, which is why we're able to say that this thing is equal to that thing, because both of them are equal to the same number. Now the other thing about the point of intersection is it's not just the y coordinates that are the same, the x coordinates also have to be the same as each other, right? So the x coordinate for line 1 has to be the same as the x coordinate for line 2 at the point of intersection. So what that means is that when we're trying to solve this equation, we should be getting one value for x, and that value for x is going to be the x coordinate of the point of intersection, and it works for both lines. So we could sub in that x value into here or into here, and it should spit out the same y value for both. So if this isn't the answer, but if the x coordinate for the point of intersection was 3, then we should be able to sub in a 3 here and a 3 here, and we should get the same number come out for y. And so if that happens, if you plug in the same x value for both equations, and it spits out the same y value, that's how you know you found the point of intersection. So how do we actually find that? Well, the first step, once we've written out this equation like this, where we've made it all one giant equation, is we know that if this left side, is equal to the y in the middle, and the stuff on the right side is also equal to the y in the middle, that means that this left side over here has to be equal to that right side over there. So what I can do is I can just basically I can ignore the y in the middle and just say that the left side is equal to the right side. So we've got 1/4x plus 1, that's the left side, equals, and then I'm going to ignore the y, and I'm going to just throw in whatever's on the right side. So that's going to be 2/3x. So now we have an equation that has no more y's in it. It's just got x's and it's got numbers, and we know how to solve an equation like that for x. I'm going to get rid of this graph because we didn't draw it very well. We'll redraw the graph in a couple of minutes. So what we're going to do is we're going to take this equation that we have down over here, and we're going to solve for x. So if we do that, well, let's start by collecting all the terms with an x in them on one side of the equal sign. Now for me, I'd like to avoid having a negative sign if it's possible for me to avoid it. So I'm going to look at the two terms that have x's, this one, and I'm going to notice that 2/3 is, if you think about it in terms of like a pie, if you've got 2/3 of a pie, is going to look something like this. The region I'm shading in is 2/3 of the pie, right? So that's this 2/3 over here, and the other term is only 1/4. So for me, the way I would go about it is I want to avoid a negative sign wherever possible. So because I've got 2/3 x over here and 1/4 x over there, I want to be subtracting the smaller one from the bigger one. So I want to do the larger fraction minus the smaller fraction, because then I'll still get a positive number. Right? Either way, I'm going to have a subtraction problem somewhere, because either I'm going to be moving the 2/3 x to the left, or I'm going to be moving the 1/4 x to the right. So some way, because they're already both positive, when I move them over to the other side of the equal sign, they're going to become negative, and it's going to give us a subtraction problem. Now, what I want to do is avoid having that minus sign. So there's no wrong way to go about it, it's just what you prefer, what you find more convenient. So for me, I'm going to notice that 2/3 is larger than 1/4, so I want the 1/4 to have the minus sign in front of it, so that when I do the subtraction, I get a positive answer. So if I do that, basically what I'm saying is I need to move this 1/4 x over to the right side. So if I do that, then the new equation will look like this. The 1 stays there on the left, so we get 1 equals, the 2/3 x is also fine, that doesn't move. And then now I take that 1/4 x, I throw it over to the right side, and it goes from positive to negative. So now we have a subtraction problem on the right side. So now what I want to do with that right side is I want to collapse it down into just one term, right? I've got 2/3, x could be anything, right? X could be apples. I've got 2/3 of an apple, I take away 1/4 of an apple, I might as well write it in just one fraction, right? And we know how to do that. So in order to subtract these two fractions, we can even ignore the x right now. I'm going to write it like this. I'm going to ignore the x by pulling out the x to the end there, so like that. Basically what I've done is, if you guys remember from a while back when we covered the distributive property, basically I've done the distributive property in reverse. If I multiply this whole thing by x, each term is going to have an x attached to it, which is what we see up here. So I'm just writing it like this so that we can sort of push the x off to the side and forget about it just for a second while we sort out what this fraction is in the middle. So if we go through that, we need, because it's a subtraction problem involving fractions, we need to make sure we have a common denominator. So to do that, we're going to figure out firstly what the denominator needs to be, and this is something that we've covered before, so I won't spend too much time actually finding that common denominator, but basically the easiest way, and it works out in this case, the easiest way to find that common denominator is to just multiply these two denominators together, and that'll be our new denominator. So if I multiply these two denominators together, I'll get a 12 for my denominator, so I get a 12 here, and it's still going to be a subtraction problem, and a 12 there. We need to figure out what the numerators are, and we can't forget about that x on the end. So to get from a denominator of 3 to a denominator of 12, I need to multiply by 4, right? But if I'm multiplying by 4 on the bottom, I also need to multiply by 4 on the top. So then my numerator will be 8. And then for the other one, for the 1/4, I'm multiplying the 4 by 3 to get to 12. So if I'm multiplying by 3 on the bottom, I need to multiply by 3 on the top, and I get a 3 in there. Hopefully this is going at a good speed and not too fast or too slow. But now, because we have a common denominator, we can go ahead and do that subtraction. So we start with 8/12, and we take away 3 of those 12ths, we'll be left with 5/12. And then we can throw on that x there. Now, I don't want 5/12 of x, I want just x. So I need to divide both sides by 5/12, right? So I'm basically, now I need to do 1 divided by 5/12 is equal to 5/12 x divided by 5/12, right? That's what we need to do. And so if I've got x here being multiplied by 5/12 and divided by 5/12, those will completely disappear from the right side, and I'll be left with just x. And then on the left side, well, 1 divided by 5/12 is the same as 1 times 12/5. If you remember division of fractions, right? That's going to be 1 times 12 over 5. That's the same thing as basically what we do is we take that second fraction, or that second term, we flip the fraction over and we change the division sign to a multiplication sign. So what we're left with then is 12 over 5 is equal to x. And if you'd prefer to write that as a decimal, just so that it's easier to tell what we're doing when we're graphing it, you could do it as a decimal, you could do it as a mixed number. This should give you 2.4 as a decimal. So what we're going to do now, we're not quite finished the problem, but now we have in this corner our x coordinate for the point of intersection. So I'm going to just throw that over here so that I don't lose it when we try to graph this in a few minutes. So what we have is, actually maybe I'll throw it up here just so that it's, no, we'll put it over here. X is equal to 2.4. Great. Okay, now I'm actually going to, when I sub it in to figure out the y coordinate, because we're dealing with fractions in our original equations, I'm going to use this fractional form for our x coordinate of the point of intersection, just because it'll make the math a little bit easier than trying to multiply fractions and decimals together. So it's x is equal to 2.4, but we also know that as a fraction x is equal to 12 over 5. So if I use it that way, if we've done this right, then when we sub in the x value of 12 over 5 into either equation 1 or equation 2, it should spit out the same answer for y. So let's do it both ways. We'll start off by subbing it into equation 1. So if we sub it into equation 1, then we get that y, so let me note down that this is equation 1. So we get y is equal to 1 over 4, and then instead of x, I'm going to write in 12 over 5 plus 1, right? So if we go ahead and calculate that, well, firstly, the 12 and the 4 can cancel out, right? So we'll be left with a 1 on the bottom here and a 3 on top over there. So what we get is y is equal to, well, we've got 1 over 1 times 3 over 5 plus 1. And so, well, 1 over 1, that's just 1. So 1 times anything is just going to be whatever that second thing is. So we get y is equal to 3 over 5 plus 1. Now we can add these together. We can write it either as, you could write it as a mixed number and just say y is equal to 1 and 3/5, or you could rewrite the 1 with a common denominator and write it as 5 over 5, right? The reason we're using 5s is because our denominator over here is a 5, so then we get a common denominator like that, and we can then just add those numerators together. And so what that'll do is that'll give us an answer of 8 over 5 for the y coordinate. So I'm going to write that in over here just so that we can double check it in a second. Y is equal to 8 over 5. Now again, if we wanted to write that as a decimal, we could write that as 1.6. So that's the same as punching 8 over 5 into your calculator. It'll give you y is equal to 1.6. So that's all the different ways we can write it. But before we go ahead and graph it, let's just double check by plugging in this x value of 12 over 5 into the second equation, just to see if it comes out to the same number. And if it does, then we can be quite confident that we've done this right. I think I can get rid of this now as well. Great. Okay, so plugging it into the second equation, we have y is equal to 2/3, it was 2/3 x. I'm going to sub in 12 over 5 in place of x. So now if we do that, well, the 3 and the 12, those will cancel. We'll be left with a 4 on top and a 1 on the bottom. So then we have 2 over 1 times 4 over 5. Multiplication of fractions, you just multiply the numerators together, that'll give you 8 on top. Multiply the denominators together, that'll give you 5 on the bottom. So that gives us the same y value, which is 8 over 5, or 1.6. And so now we can be fairly sure that we've done this correctly. But if I just go through this really quickly and try to graph these, just so that we can double check if our answer is right, let's throw our x and y values in a place where we can read them a little bit more easily. So we'll put x is equal to, now I'm going to write them as just decimals, x is equal to 2.4 and y is equal to 1.6. So we can estimate, when we draw our graph, we can estimate whether the point of intersection seems to be pretty close to the values that we got, or if they're way off. So let's give that a go. If you don't feel like graphing this, that's fine. I'm going to go through this kind of quickly because I want to do one more example. If you are graphing this, don't forget to label your axes x and y. We'll throw in these tick marks. And just to save time, because we're going to do another problem after this and I'm going to have to erase the grid, for this one I'm not going to draw in the dotted lines. I'm just going to sort of eyeball it. So for our first equation, our y-intercept is this +1 over here. So that's telling us that we're going to start right there on the y-axis. And then our slope is 1 over 4. So our rise is 1, right? We've got a rise of 1 and a run of 4. So that's telling us that for every 1 unit we move up, we need to move 4 units over. So if I do that, I go up 1, and then I go over 1, 2, 3, 4 to about there. And if I do that in the opposite direction, then instead of going up and to the right, I'm going down and to the left. So then I go down, and then 1, 2, 3, 4, and I end up over here. And then if I try and connect those dots, I'll get something that looks like this. It's not perfect, but I think it's good enough. And then for the second line, well, that's 2/3 x. So because there's no y-intercept, that's telling us that the y-intercept is 0, right? Because it would be this +0 on the end. So the second line will intersect right at the origin. And then we have a slope of 2/3. So that's telling us now that our rise is 2 and our run is 3, right? This is going to be hard to squeeze in, but our rise is 2 and our run is 3. So that means for every 2 units I go up, I have to go over 3. So I go up 1, 2, and I go over 1, 2, 3, somewhere right there. And then I can do the same thing in the other direction. I go down and to the left. So I go down 1, 2, and then over 1, 2, 3, somewhere about there. I don't think that's perfectly straight, but should just about do the trick. Something like that. And obviously I haven't drawn this quite perfectly, but right around here is our point of intersection. So we can see that even though the drawing isn't perfect, it's kind of close the way we've drawn it right now without using a ruler or the grid lines or anything. We can see that the x value is somewhere between 2 and 3 and leaning a little bit closer to the 2 side, so this part makes sense. And then for the y-axis, the y coordinate is somewhere between 1 and 2 and leaning a little bit in the direction of 2. So that also kind of makes sense. Alright, so there we go. That's our point of intersection for this example. So then you could say that your point of intersection, POI, is at 2.4, 1.6. Or you could put that in fractional form if you wanted. You could say 12 over 5 and 8 over 5, or you could make them mixed numbers if you wanted to, and say it as what, 2 and 2/5 and 1 and 3/5. So you have some options for how you would want to express your final answer, but that's the process. The process is what we're focusing on here. So for the last one, I'm going to go through it a little bit faster once we get through the hard part. And the hard part is that when I set up the question, when I give you the question, the equations for the lines aren't going to be written in the format that we would expect to see them. So they're not going to be written like y equals mx plus b. It's not going to be super crazy different, but it might be like, I might, instead of having y is equal to something, I'll have 2y is equal to something, or 3y is equal to something, and then we're going to have to end up getting that y all by itself. We're going to try to rewrite it in the more familiar y equals mx plus b kind of form. So actually I did work this out earlier. Let me pull that up beside me just so that I know what I'm doing. Okay, yeah, so here's our last example of the school year, I guess, related to the material that we've been focusing on at least. Okay, so for this one, your first equation is 2y equals x. Alright, and your second equation is x plus y plus 1 equals 0. Alright, so our first step is we want to rearrange these two equations into a more familiar form so that we can work with them a little bit more easily. So, if I rearrange number 1, I'm going to write in rearrange right there. So if we rearrange this one, basically we want it in a form where y is by itself and everything else is on the other side. So what I have now is on the left side I have 2y and I want just y. So the easiest way to do that is I'm just going to divide both sides by 2. So if I divide both sides by 2, if I divide the left side by 2, I'll be left with just y, right? 2y divided by 2 is going to give me y. And then on the right side, x divided by 2, well, I can just write that as x over 2. Or if you want, you could, if it's easier, you could write that as 1/2 x. It's the same thing as x over 2. Just this way, it's just it might be a little bit easier to see that here's the slope and here's the x. So like this is our mx, and then we don't have a plus b. Our intercept is 0 for this one because we don't have anything written there. Alright, so now let's rearrange the second one. Rearrange the second one. So we're trying to get it into that y equals mx plus b format. So the y is not being multiplied by anything. So we don't need to multiply or divide this by anything. All we need to do is take this x over here and this 1 over there and throw them onto the other side of the equal sign. So basically I'm taking this x, throwing it to the right side. I'm taking this 1, throwing it to the right side. Now because they're both positive here, right now it's positive x and positive 1. When I take them to the other side of the equal sign, it'll be negative x and negative 1. So the y stays by itself. We have an equal sign. Oh, that's not an equal sign, that's just a big block. Y equals, and then we'll have, when the positive x goes over, it becomes negative x, and then when the positive 1 goes over, it becomes negative 1. So there we go. Now we've rearranged the two equations into a more familiar form. We don't really need the plus 0 there. But there are the two equations of the lines that we're using in this problem. So now, it's the same process as before. So this is where we can speed it up a little bit, hopefully. The idea is that at the point of intersection, the y values are going to be the same. So that means that this number and this number have to be equal, which means that this thing has to be equal to this thing, because they're both equal to the same number, whatever y ends up actually being. So that means I can write this as from the first equation. Here's our new equation 1, put like a star beside it, and here's our new equation 2, star beside it. So from our new equation 1, we get that 1/2 x is equal to y. And then from our new equation 2, we know that y is equal to negative x minus 1. So I can put that in all in one line right over here. So this first part right here, this is from the new equation 1, and this part is from the new equation 2. Alright, now, if our left side is equal to the middle, and the middle is equal to the right, that means that the left side has to be equal to the right side. So I can just completely ignore this y in the middle, and I can just write out the left side is equal to the right side. So I get 1/2 x is equal to negative x minus 1. And now from here, it's the same thing as always. We just want to solve for x. So I want to get all the x's on one side and all the numbers on the other. So what I'm going to do is I'm going to take this negative x, I'm going to throw it to the left side so that we get 1/2 x plus x equals -1. We can't forget this negative sign sticks with the 1, right? So then we have 1/2 x plus x. It's plus because it was negative on the right side, so then when we bring it over it becomes positive down here. So we got 1/2 x plus x is equal to -1. So solving for x, 1/2 x plus x, if you go through that, that should give you 3/2 x, 3/2x. That's like saying you got a pizza plus half a pizza. You've got 1.5 pizzas, which is the same thing as 3/2 of a pizza, right? So if that's not making sense, just try and think about it, because it's the same thing that we've done before, right? Where you've got one whole pizza, right? And then 1/2 of a pizza. Well, this right here is a half, this right here is a half, this right here is a half. So in terms of counting the halves of pizza that we have 3/2 of a pizza. So that's where this 3/2 comes from. And then on the right side we've still got that -1. So now we're going to go through the same process that we had in the last problem, where we don't want 3/2 x, we want just x. So I'm going to divide out by this fraction, where the shortcut is basically going to be that on the left side we're going to make sure it cancels out, right? But basically what we're doing is 3/2 x divided by 3/2, which means I have to do the same thing on the other side. So -1 divided by 3/2, like that. So on the left side I've got x times 3/2 divided by 3/2. The 3/2 disappear, and I'm left with just x. On the right side, that's going to be -1, and then we do the same thing that we've always done for division of fractions, is I'm going to flip the second fraction to 2/3 and put a multiplication sign in the middle. So what we find then is that x is equal to -2/3. Alright, so there's our x coordinate for our point of intersection. And now we're almost done, because we just need to find our y coordinate for our point of intersection. So what I'm going to do is I'm actually going to erase the original equations, these ones over here, because they're not as useful to us as our new ones over there. So if I erase this stuff here, let's get rid of up to there. So now I want to use this value for x, -2/3, and I'm going to plug it into one or both of these. Now if you plug it into equation 1, you'll get that y is equal to 1/2 of, right, 1/2 times x, where x is -2/3. And if you do that, well, these 2's cancel, and you're basically just left with y is equal to -1/3. Right, that's 1 times 1 on top, 1 times 3 on the bottom, and then the minus sign stays with it. So you get -1/3 for the y value if you plug it into equation 1. And if you plug it into equation 2, or the new equation 2, then, yeah, that's the new equation 1 and the new equation 2, then you'll get that y is equal to okay, so we got -2/3, like that, -1. Now, -2/3 is the same thing as +2/3. So we've got +2/3, and then we're subtracting 1 from that. So basically what I'm doing is +2/3 minus, well, 1 is the same thing as 3/3. So if I do 2/3 minus 3/3, I'll be left with -1/3. And so that shows us that since we plugged in the same x value and it spat out the same y value for both equations, that we can be pretty confident that we have done this right. So just really quickly, I'm going to write in down here, we've got y is equal to -1/3, and we'll just really quickly graph it. Now, a comment on when you're calculating the y value, you don't have to plug it into both equations. That if you do plug it into both equations and it gives you the same number, that's a way to check that you have done it right. but it's not a requirement, and it's also not a requirement that you graph unless it's been asked of you. So if I'm asking you to find the point of intersection and I don't say anything about graphing it, then you don't have to actually graph it. Now, of course, there's no test on any of this stuff, but in future, you know, if I'm still end up making these videos for you in the summer or next year or whatever, then if we revisit this then that's an important point to note. Don't make more work for yourself. If you don't have to graph it, don't worry about graphing it, as long as you're confident that your answer is correct. So what we'll do is we'll graph this super quickly. We've got something like this. Alright, so we've got our tick marks going this way, tick marks going that way. My axis is a little bit short. -1, 0, 1, 2, 3, 4. Label your axes. 3, 2, 1, -2, -3, -4. Alright, sweet. So, from here, if I just really quickly, just because this is our last example, so I can afford to put this up and then leave this up, we'll just draw in these dotted lines. Something like that. Something like that. This one's a little too high, I think. And then another one down here, but this one's not really that important, so don't worry too much about it. Okay, something like that. Okay, so now we want to plot. Let's start with the first one. So we've got y equals 1/2 x. Notice that I'm using the new equations because it's easier to graph the ones in a familiar format. This is the type of equation that we've worked with before, so we're going to use that. So there's no y-intercept, so that means we start on the origin, and then our rise is 1, and our run is 2. So that's telling me that for every unit I go up, I need to go 2 units to the right. So I go up 1, and then I go over, so I go up 1, and I go over 2. So to right there, I can do the same thing again, up 1, over 2, to right there. I can go in the opposite direction, down and to the left, so 1, 2, and 2, over there, and down, over, to right there. And then I can connect all of those. Something like that. And there's our line. Y equals 1/2 x. And then for the second one, well, we've got an intercept of -1. So that means we're going to start here. And now our slope is, we've just got a minus sign here. So that's the same thing as saying our slope is -1. We just stick a 1 in there. And because it's negative, that just means that for every unit we go down, we have to go over to the right 1 unit, right? So if it was +1, we would go up 1 and right 1. Because it's negative, we go down instead. So we go down 1 and over to the right, so right here, down and over to the right, down and over to the right, like so. And then in the opposite direction, we'll go up and to the left, which is a little bit more confusing because we're not used to that, but it'll put us here, here, and here. And after you've drawn a few dots, you can kind of see the pattern, right? So then you can just connect all of those with a line, like so. And this would be our second line, -x minus 1. And so then we can see our point of intersection is somewhere right over here. This is where the -1 mark is on the x-axis. This is 0. So we can see that our intercept on the x-axis is between 0 and 1. It's maybe cheating a little bit more to the side of 1. So that's this right here. This, as a decimal, would be 0.67 approximately, or -0.67. So we can say that that's pretty reasonable. And then in the y direction, here's 0, here's -1. And so our y coordinate is a little bit less than halfway through, which makes sense with what we've got down here, because the y coordinate is about -0.33. So we can be reasonably sure from our graph, the way we've drawn it here, that these values are correct, because even if our graph isn't perfect, we can see that it's pretty darn close to what we were expecting to see. We were expecting to see small numbers, both negative for x and y, and both between 0 and 1, and that's exactly what we've got here, so we can be pretty confident that we've done this right. That, and when we plugged it into the equations, it gave the same answer in both equations, so we've got no indication that we've done this wrong. So yeah, so we can be pretty confident that we have done this correctly, and that is a great way to end off this school year, is by doing this example right. Unfortunately, I don't have any sort of homework. I mean, maybe it's fortunate for you guys, I don't have any sort of homework on this stuff for you, but yeah, so this is our last lesson that's on the things that I actually wanted to go through with you this year. I'm not sure when you'll be seeing this, if you'll be seeing this on the last day of school or in your second last math class. I'm going to put out one more, at least, just in case you finish this one a little bit early. But other than that, I hope you all have a great summer, and hopefully I will see you either in more videos over the summer or perhaps sometime next school year or other times in the future. But yeah, so if you, as always, if you have any questions, send me an email, leave me a comment, get in touch with me in any way you can, and we can go through whatever you're struggling with or curious about. But other than that, I will see you all in the next video. Have a good one.